Good morning, everyone. Thank you for joining us today at the University of Pretoria. We are sitting in the Engineering 1 building, and we will shortly go down to the battery room that supplies power to the study centre in Engineering 1. The battery and inverter system was donated to the University of Pretoria by Freedom 1, and we're actually here today to do the official handover.
I'm Alta van der Merwe. I'm a professor in the Department of Informatics, but also the Deputy Dean Teaching and Learning for the EBIT faculty. The University of Pretoria is now, if I remember correctly, about 116 years old. It was created or started in 1908, I think, with 32 students. So it's got quite a long history, and it's very large now. We have quite a few campuses, and we offer almost everything that is out there: engineering, medical, humanities, veterinary. It's quite an extensive university. It's one of the big 5 top universities in the country. Currently our world ranking is 354 for the QS ranking, which is the most important ranking. So what I can say about the EBIT faculty, currently we produce about 28% of all the engineers in South Africa, which is quite significant. From all our degrees in the EBIT faculty, a lot of it's accredited. That means that you can move easily from South Africa to another country. We have a combination of 4 schools: the School of Engineering, the School of Built Environment, Information Technology, and then GSTM, which means we have about 350 staff members, academic staff members that serve this community of about 11,000 students in total if you count the undergrad and postgrad. I don't want to know how much it cost this university. It was the amounts of diesel that was burnt and so on during load shedding was immense. So for us, the study centre is the heart of the students at the University of Pretoria, at the engineering faculty, where we have study rooms, we have computers. So when that is offline, there's a lot of students, especially from our disadvantaged groups, that don't always have access to computer at their home centres or internet or so on. So they come and work here. So when the power was down, it was really a big problem. And I think that is where the biggest contribution is of this. For a university like this to get to a standstill, you can just think what happens if we have exams scheduled in the study centre and suddenly the power goes down. Now we can have 24 hours a day access to power and be able to serve our students better in that regard.
My name is Hendrik Rasebopje. I'm a Deputy Director in the Facilities Management, responsible for technical services. Like Prof said, what we need is uninterrupted operations for engineering students. And what I can say as well in terms of this donation is that it's a pilot for us to say this system is working, maybe let's venture into this kind of system. Our generator systems, actually when we install them, we envisage that it's going to be backup power, not to run longer than 6 hours. Maybe when we have an emergency, 1 hour or 2 hours, not more than that. We had to run our backup power systems more than it could handle. So with that, it became a problem in terms of maintenance.
I'm Victor Sieta. I'm the project engineer within the Technical Services Department, responsible for both electrical and electronic projects. The increased maintenance needs that were exerted onto the current system of the generators that we had resulted in increased costs. It resulted in more rentals of generators that we didn't have due to failures. It also just disrupted the academic activities in terms of the use of the facilities. In some instances, labs could not be used. Exams had to be deferred to a later date to accommodate for backup plans to be put in place. From an operational point of view, in terms of man hours, we will note that the student center is a -1. We don't have to deploy additional staff members to take care of the generator that looks after this facility. And Yeah, I think for us it also creates an environment where we as the maintenance staff can use this pilot to further understand and employ it at other different sites throughout the university.
In case of our sustainability and carbon footprint, the university yearly we have to report on our sustainability and carbon footprint reduction, and then we have certain goals like targets that we need to meet, and we submit our report to the Department of Higher Education and Training. So in terms of the carbon footprint, we're trying to reduce our generators. We have, I think, 80 generators on all our campuses. So with this kind of project that we did with battery backup, it's a -1 for us, which is a good thing for us in terms of reporting our carbon footprint.
Initially, when we decided to go ahead with the project, we had to perform a risk assessment, and this risk assessment was mostly about how to move the equipment into place, what equipment we'd need for lifting, and the qualified persons. And the other particularly important part of the risk assessment was how would we isolate the electrical supply so that we can connect the system safely. Just as a side note, the tie-in to the system had to be done on a weekend when there were hopefully no students requiring the study centre at the time, because the power had to be off for about 1 hour. So right up front, the university requested that we design a system that doesn't need a generator. Our strategy was to install a system that could run the whole study centre for 8 hours at the average loads. And of course, a battery inverter, that's the battery capacity. And then the battery inverter itself had to be sized to accommodate the maximum load in the facility. And we did that by analysing the last 12 months of load data that was provided by the university. And we also established that what the average load was during that time. During the design, we considered how we would ensure uninterrupted power supply to the study centre in the case of us needing to do maintenance. And this would involve us being able to bypass the system to grid directly without interruption. And this is possible with the battery inverter, because the battery inverter output is synchronized to the grid when the grid is on. So if you bypass grid directly to the output in this synchronized state, and there will be no interruption of the output power to the loads. So the Freedom One megaTower Plus battery that was used in the UP project was launched very early in 2024, and it is a new product developed to suit large commercial and industrial applications. The megaTower Plus runs at 691 volts for the engineers amongst us, and that is directly suited to operate with the 8S PCS 250 inverter that we have installed on this project. And then the system also includes the 8S bypass cabinet, which is your grid interactive device that will disconnect the grid if the grid goes down, so to speak, very quickly, so that the battery inverter can take over without any interruption in the power supply. During this discussion phase, we also realized that we need to install a battery inverter that can handle potential future growth in the loads. And we also ensured that included in the specification we had a battery monitoring system in each battery in the megaTower, so that Freedom One can provide really high level service of support to monitor the battery and to ascertain its usage patterns and optimize its usage, and also to monitor its performance and health. The other part of this design was the overall system monitoring system or platform. that allows us to have a dashboard that monitors the performance of the system in a simplified, so real-time fashion. And it also allows us to go back in the history and look at graphs of the overall system performance. It gives us a lot more flexibility or data understanding to set up a specific site protocol that allows the system to avoid using the grid in peak tariff times, and also allows us to keep our maximum demand at a much lower level than it would otherwise have been. The Freedom One product is considered the most suitable, superior solution for an application like this for many reasons. So from a client's perspective, they have the peace of mind that Freedom One is a local company that has a local manufacturing capability. We have a large technical support team that can be deployed to a site that may be experiencing hassles. We have a strong engineering team that can support the customer from the right up front with selecting the right equipment and the overall project design. We have a team of commissioning engineers that ensure that the system is commissioned correctly and the transition and handover runs smoothly. And also the product itself has been developed through 12 years of pedigree, so to speak. That is how long Freedom One has been designing lithium batteries for stationary applications. And this particular product offers a modular approach, so it allows for easy site installation. It also allows for easy maintenance, so removal of a module to inspect something, or replacement of a module should there be a problem. The system also allows for a very easy expandability. So more battery capacity can be added, more inverter power can be added. During the installation, it's always very important to ensure safe work practices and that everyone is properly trained and accredited for the role that they are playing in the installation process. This type of work must always comply with the Occupational Health and Safety Act and in terms of the actual operation. And the way it's installed and the standards that must be followed is governed by specific codes or standards issued by SANS, the South African National Standards. So the partnership with the University of Pretoria in this initiative doesn't stop with us handing over a completed battery energy storage solution. It actually is much bigger than that, because it now offers students, electrical engineering students, the opportunity to interface and engage with the system directly on their own campus. And there's many opportunities for training and exposure to the technology. Also a much bigger picture for the long-term relationship between Freedom One and the University of Pretoria, in that many of our engineers are actually alumni of the university, and we strive to promote the study of engineering and the mentoring and the employment of engineers in our business that have studied the applicable courses from the University of Pretoria.
Throughout the whole journey, the constant communication from Freedom One team, whenever you needed information, they were willing, they were forthcoming with the information, they were engaging.
Like Victor has alluded, that the professionalism that we experience and the delivery, there wasn't a grey area on where to deliver.
What stood out from Freedom One is the fact that they committed when they promised something, and it happened quickly. It wasn't a long delay, or we talk and we talk and we talk. It was, we're going to commit and we're going to contribute to the university, and they did.
From the management team, it would have to be what was critical and key was the communication. It was constant, it was forthcoming, it was correct. So I think those for me was actually what led to this being a success that it became. So thanks to the Freedom One team.